Hey guys, welcome back to my CCNA 200-301 course. In this video, I'm going to show you how trunking works between switches and how you can communicate different VLANs between the switches. Are you ready? Let's get started. Alright, this is our today's scenario, which is the same as the previous video. And again, we have switch 1 and switch 2 and two different subnets for our PCs. The only thing I did within the previous video and this video is I put Ethernet 0/1 here and 0/2 here in VLAN 2. So I want to show you how trunking works and how you need trunking when you have multiple VLAN across different switches. So at the moment, all of these interfaces except Ethernet 0/1 and 0/2 here, they're all in VLAN 1. So PCs which are in VLAN 1, which includes PC1, PC5, and PC3, can communicate to each other, but PC2 and PC4 cannot communicate to each other, although they are in the same subnet. Why? Because this interface, which communicates to switches, actually is in VLAN 1, so it cannot transfer VLAN to traffic. This is where we need actually trunking, so we can carry different VLAN traffic. So now, if I go to PC1 and ping 192.168.1.3, which is in the same switch as myself, obviously I can ping it because we're in the same VLAN on the same switch. And also if I ping 192.168.1.2, which is in VLAN 1 on the other side, I'd be able to ping it as well. But if I go to PC2 and ping 192.168.2.2, I'm not able to ping it because my traffic doesn't go through the link between the two switches. Before we dig into trunking concept, I need to talk about a specific protocol. A protocol called DTP, or Dynamic Trunking Protocol. DTP helps Cisco switches to negotiate about the protocol they want to use for trunking, which is useless these days because Cisco switches only support .1Q at the moment and they do not support ISL anymore. And the other purpose of DTP is actually if the interfaces are ready to become a trunk or not. So negotiating about being trunk at all or not. That is the second purpose of DTP. With regards to the first role of DTP, if your switch supports both ISL and .1Q, you can go to the desired interface like Ethernet 1/0, which is our interface between our switches, and say switch port trunk encapsulation, and you have three options here: .1Q, ISL, or negotiate. If you don't have this command in your Cisco switch, which is probably you don't in recent switches at least, that means your switch does not support ISL. So if you're using an old switch, you will be having this option. So .1Q means you want to use .1Q, ISL means you want to use ISL, and negotiate means look at the other side. If the other side uses ISL, you use ISL too. If the other side uses .1Q, you use .1Q as well. So this command is deprecated on many Cisco switches, as I mentioned before. For the second part of DTP role, we have switch port mode command. We have a few options here too: switch port mode access, switch port mode dynamic, and switch port mode trunk. These are the options that we want to talk about it. We don't want to talk about the other options. Dynamic has two options. If I pick dynamic here, you can see that I have dynamic auto and also dynamic desirable. Let me open a page and show you what would happen in different situations when you have one of these options on one side and have the other options option on the other side. All right, this is the table that comes from Cisco CCNA reference guide, and it is very important, and you have to memorize the contents of this table. But it's not a big deal. If you understand how these different modes work, this table will be very easy for you. If in front of your switch port mode command, you say access, it means you don't want to negotiate about being trunk. And this port has to work in access mode, which is recommended to be configured on interfaces that are connected to endpoints like PCs, servers, and etc. And also switch port mode trunk means I don't want to negotiate to being access. It has to be trunk. But dynamic auto and dynamic desirable bring some negotiations for you. With dynamic auto, switch will negotiate about being trunk or access, or actually being trunk. But it doesn't initiate the trunking or the negotiation. On the other side, dynamic desirable negotiates about being trunk, and it initiates the negotiation as well. So if you have one dynamic auto, I mean an interface with dynamic auto settings on one end, and also dynamic auto on the other side, the result would be access, because no one initiates negotiation about being trunk. But if you have one dynamic desirable one side, the other side dynamic auto, the result would be trunk. And consider that dynamic auto is the default setting for all Ethernet ports on Cisco switches. Two of these cells have do not use recommendation. If you configure one side as trunk and the other side as access, this is not recommended. You either want an interface being an access or a trunk. So setting one side trunk and the other side access doesn't make sense. So it is not recommended, and it may create some problems for your communications as well. So Cisco does not recommend you to set your switch port modes like this. And you can have a look at the other parameters with the definition of access, dynamic auto, trunk, and dynamic desirable. You can guess the other cell information as well. Now we go back to our switch 1, and on our interface, Ethernet 1/0, which is supposed to be a trunk interface, and run switch port mode either dynamic desirable or trunk. Okay? It says command rejected. An interface whose trunk encapsulation is auto cannot be configured to trunk mode. Since these emulated devices are basically layer 3 devices, you have to make another change here as well. And that is switch port trunk encapsulation .1q, which I need to do. And also, then we go back to the other command and say switch port mode trunk. On a real Cisco switch, you don't have to run that switch port trunk encapsulation command. Now we go to switch 2 and replicate the same commands. So we go to interface Ethernet 1/0 and say switch port trunk encapsulation .1q, and then switch port mode trunk. To be able to see the status of your interface in terms of either it is an access port or trunk port and other layer 2 or layer 3 information, we can use a couple of commands at this stage. The first one is show interface and then your interface like Ethernet 1/0 and then the switch port. Some valuable information is here. First of all, switch port enabled, which means this interface is in layer 2. As Cisco has some MLS switches or multi-layer switches, in those switches, this information would be very valuable. So you can understand if this interface is in layer 2 or layer 3. But in layer 2 switches, it's always enabled. Administrative mode, which means what did you set as an administrator on this interface? As you remember, we set it as trunk, but what you set doesn't mean in operation will be happening and will be applied. So you have to check the operational mode as well. In operational mode, it is trunk. Okay, fantastic. We set it as trunk, and operationally it is trunk too. And what is the trunking encapsulation? It is .1Q. So it looks we are good. The other command you can use about if you have any trunk interface, specifically related to trunks, not all access or trunk interfaces. It is show interfaces trunk. This command will show you what interfaces on your switch are working in trunk mode and which VLANs are allowed on those interfaces. Okay? So, as you can see, we have port 1/0. Mode is on, which means it's been manually set to be trunk. And then the encapsulation is 802.1Q. The status is trunking. And the native VLAN is what? You remember that we spoke about native VLAN. It's been introduced in .1Q. And the frames that are in native VLAN won't be actually tagged and will be sent to the other side. And as you can see, Ethernet 1/0 allows all VLANs, although we haven't defined these VLANs, but based on the settings, which is the default settings, the trunk interface will allow all VLANs. And also, which VLANs are active at the moment? VLAN 1 and 2. Which VLANs are in forwarding state and not pruned in a spanning tree? None. We'll be talking about spanning tree in later videos. But for any reason, specifically for security reasons, you may need to restrict the available or allowed VLANs that can traverse over your trunk interface. To restrict or actually control what VLANs are allowed to go through your trunk interface, you go to your trunk interface and say switchboard trunk and then allowed VLAN, and then you have some options here. VLAN IDs that you want to allow them, like 1 to 10, 1 to 20, 11 to 20. And you can create a list of all VLANs that you want them to be allowed to go through that trunk. When you create that initial list and later you want to add another VLAN to the list, you will be using the add keyword. Bear in mind that it's very important. Many people make this actually problem for themselves, and they just when they want to add an extra VLAN to the list, they normally say switchboard trunk allowed VLAN and like the new VLAN. But if you add like that, that new VLAN will be override to actually the current list, and the other ones will be removed, and that VLAN will be allowed. And this can create a catastrophe in your network, so be careful. If you need to add an extra VLAN or VLANs to your list, use add, okay? And then accept. All is the default one. All VLANs are allowed to go through trunk interfaces by default. Accept, work the other way. All VLANs except this. This is useful when you're number of VLANs that you want to allow them on your trunk interface are much more than the ones that you don't want to allow. Like you want to allow all VLANs except 10 of them. So in that situation, except will be useful. None means no VLAN, which is and it doesn't make sense to me why we need to make an interface trunk and then do not allow any VLAN. But there is an option if you need it for any reason. And then remove is the other side of the add. If you have a list and you want to remove one of them, you can remove that VLAN from your list. As I mentioned before, when you put your interface mode in access mode, it doesn't actually negotiate about being trunk, but it doesn't actually disable the DTP on that interface. So I actually make an interface on this switch, show interface ETH 0/2. I actually made it as access, a static access. So I ran switch port mode access on it. Okay. But if I go back to my packet capture on Ethernet 2/0, I still can see DTP packets. So switch port mode access basically doesn't disable DTP. The command I want to show you actually will disable DTP on our interface. This command is, if I go to interface ETH 0/2, it is switch port no negotiate. So this command will disable DTP on your interface. Now, if I go back to my packet capture, you can see that there's no any DTP packets running on this switch interface. So that command will disable DTP completely on that interface. In some situations, you may need to change your native VLAN. Please bear in mind that if you want to do that, you have to do it on both ends of a trunk link between two switches. To change your native VLAN on the .1Q trunk, obviously, we go through that interface and we say switch port trunk native VLAN, and we give our VLAN ID that we want to use it as our native VLAN. Now I have my trunk link set between the two switches. So I'm expecting PC2 now also should be able to ping the other side. So I'm saying ping 192.168.2.2, and as you can see, I can ping it. Now, if we have a look at our traffic between the two switches, and for example, have a look at this ICMP packet, which actually shows our ping communication between the two devices. If you have a look at the Ethernet frame, you can see that we have some extra information here now. 802.1q virtual LAN. And the important thing for us is this one. This ICMP packet belongs to VLAN ID 2. So when it receives on the other side, the receiving switch knows that this frame belongs to a device in VLAN 2. So with this configuration and setup, we have our privacy and segregation in all circumstances. So no device in each VLAN would be able to communicate to other VLAN, and our privacy will remain consistent. Alright guys, this was our today's video. In the next video, I'll be talking about VTP or VLAN trunking protocol. I wish you enjoyed today's video. See you in the next videos, and thanks for watching.